Hi guys, in this video we are going to take a look at how to determine if two lines in space are either parallel, intersecting or skew. So there is a new possibility in 3D space for two lines. They could actually be skew. What that means is just imagine that you have two pieces of paper, okay? So you have piece of paper number one and then piece of paper number two. And these pieces of paper are parallel to each other. Okay, so just think of it as like two pieces of paper that do not ever intersect. And then imagine that you have a line in one of them and another line in the other one. Well, because two pieces of paper do not intersect, these lines will also not intersect, but they don't have the same direction. So they're not parallel, but they also don't intersect. And if that happens, they're called skew. All right, so how do we determine that? Okay, so the first thing you do, let's start with part A. Eliminate a easy situation, and that is if the direction vectors are multiples of each other. If that happens, then the lines are parallel and there's nothing you have to do. So to look at the direction vectors, you check the coefficients of t. So that would be like 1, -1, 4. And then also check the coefficients of the other parameter, which is 5, -5, 20. Notice how the parameter in the first equation is t, or set of equations, parametric equations, and then the second one is s. And that is because you do not necessarily have the same parameterization for the two lines. So t, you can think of it as time, and you can count time in minutes, but you can also count it in seconds, or you can start counting at 3 a.m. or 5 a.m. or whatever. So the letters have to be different. Okay, it doesn't necessarily mean that you will have exact same parameterization at the exact same time everything will happen. Okay, so you have to have two different letters. All right, so for this one though, if we divide the components like x by x and then y by y and z by z, we will get 1/5. So this is equal and this is equal, and so these lines are parallel. So that's easy. If that happens, then you are basically done with that part. So I actually drew these two lines for you so you can see that they are parallel, right? They are parallel. They don't intersect, but they have the same direction vectors in the same direction. Okay. What about part B? Now, part B, how do you figure out if then the lines are, if they're not parallel, and you could see that -1, 1, -1 is not 3, -1, 1. They're not gonna be proportionate to each other. So what happens is you have to make the x equal x. So you're gonna have 1 minus t equals 6 plus 3s. That's your first equation. The second equation is gonna be you make the y equal y. And finally, you make the z equal z. And what you're trying to do is see if this equation, if this system of equations has a unique solution, like one and only one, then the lines are going to intersect. Or maybe it has no solutions. Not really sure what the heck it keeps giving me this error. If there is no solution, then the lines are going to be skewed because they're not parallel, right? Because remember, the direction vectors weren't proportionate. Now, how do you solve a system of equations that has three equations but only two variables? So sometimes what happens is this third equation is going to contradict the previous two and you will have no solution. Or it could actually be some multiple of the previous two. In that case, you will have a solution, and that's going to be like a intersecting two lines that are intersecting, right? Now notice in this case, if I add the second and the third equation, what I will get is just 0 equals 0 because everything cancels. And so what that means is this last equation is just a multiple of the second one, so it doesn't really give you anything. So now we have two equations and two variables to solve. And we can do that by, again, adding up the left-hand side and the right-hand side. So I did that because negative t and t will cancel. So I'll get 3 equals 6 minus 1, that's 5, plus 2s. Okay, so this is going to give me s equal to -1. Okay, so once I got that, I'm going to substitute that into the first equation. So I get 1 minus t equals 6 plus 3 times -1. So that gives me 1 minus t equals 3. Okay, let's subtract 1 from both sides. So negative t equals 2. And so I got t equals -2. Now, what we should make sure that happens, that this is correct by substituting these values in all three equations and making sure that the left-hand side and the right-hand side are the same. So for example, if I substitute t equal -2 into the left-hand side over here, I get 3. And if I substitute s equal -1, I also get 3. So 3 equal 3. I can also check the second one. 2 plus -2 is 0. -1 subtract -1 is also 0. And remember, the third equation was just a multiple. So this one is intersecting. So this is going to have a one intersecting point. Now let me show you the picture for that. So those are the two lines, right? And we actually were able to find what that point was, right? So we said that let's see what the point was. So what happens when t equal -2 again to the first equation? We're gonna get 1 minus -2, so that's 3. Then 2 plus t, that's 0. And then -2 minus t, well, that's just going to be negative of the previous one, so 0. So I think 3, 0, 0 should be a point where they intersect. Let me see if I can add that point there. There, you see how this point right there, that's the intersecting point. Okay, so the last part is to solve the same thing, but now we want to probably see if we have the skew lines, right? So you can kind of already guess that that's going to be skew, but let's see why. So we're going to make them equal to each other. 3 minus t equals 13 plus 4s. Then we got -1 plus t equals -3 minus t. Oh, sorry. So you make the y equal to the y. So that's going to be -2 minus s, and then the z equal to the z. Okay, so to solve this thing, let's go ahead and add up these last two equations. So if we do that, t and -t will cancel, right? And then s and -s will cancel. And then we're going to see that -4 on the left-hand side equals to -1 on the right-hand side, which is, of course, not true. So these two equations contradict each other. So these two lines are not going to have an intersection. So this is going to be skew. All right. Well, it does not allow me to submit it, but that's okay. So let me just show you what these skew lines are going to look like. So this is the skew lines picture. Let me see if I can show you better. Okay, so there you go. See how these two lines, they kind of look like they intersect, but they really are not. So no matter how you turn them, they lie in two parallel planes, and they're never going to intersect.